We discussed logging with Slog in episode 22. There are a few more great features that we will cover in this episode. Let's start from where we left off. Now we will remove some logs and a few settings to make the output shorter and easier to understand. Here we have a group. If we want to log this information with each statement in a piece of code, we will have to add the group to all those slog statements. Well, there is an easier way. We can create a logger that will always put this group in the logs. Let's call this child logger. We can simply create this logger with slog.with method. Pass the group in this function. Now we have a new logger. Whenever we want this group to be logged, we can use child logger. Let's log some info with the child logger. Run the code. Here is the message. OS info, which was the group, is printed here. Another feature that Slog provides is to mask certain information. For example, it is not recommended to print passwords in the logs. Let's add a new key-value pair for the password. Now we want to mask the value of the key called password. In handler options we can specify the replace attribute field. This field is essentially a function with this signature. Let's copy the signature. The parameter A is the key-value pair to be printed. If the key is password, set the value to a string value called masked. Now return the attribute. This should mask the password. We have made a mistake here. The signature of the function is incomplete. We missed the return type. It should be slog attribute. Let's remove the child logger and use slog instead. Run the program. Here the password gets masked. In a real scenario, we might want to mask more than one key. Let's change this code to cater to such a situation. Let's move the replace attribute function out to make things easier visually. Suppose we have two keys to mask. Create a new slice of strings. Say, we want to mask the passwords and pub/sub channel name. create a variable exists that tells if the key exists. Initialize it to false. We define a new variable, key to find. To make it case insensitive, let's downcase the key. Now loop over keys to mask, and if there is a match, set the exists variable. If the key exists, replace the value with the masked string. Let's see if this works. Yes, it does mask the password value. This is how we mask specific fields. But what if we want to mask sensitive information from a model or a struct? Let's look at this example. We have a model defined here called user. Here, the logger is set up. A new user is created here. And here we log it. Let's see how it prints the information. Sensitive information like name, email and password gets printed here. This is not advisable as this could be the potential source of information leak in the system. There is a simple way to avoid such mistakes. We need a function named logValue on the model or the struct user that returns the slog value. As the ID is enough for logging, we can simply return the value of the ID. Let's see what happens now. Now only the ID of the user is printed. We missed a simple thing in part 1 of the slog episode. Let's say you want the source of the log to be printed along with the log. In the handler options, just set add source to true. Let's do a little formatting. Now a new group called source gets added to the log. It provides information like the function, the file, and the line number. Many folks like to write the logs in a file instead of standard error. Let's see how we can do that. We open a new file here. We are going to write in the temp directory. The file name is slogdemo. We need to specify flags to open the file. Let's set these flags. The first flag is create. It helps us create the file if it does not exist. The next flag, append, appends to the file if it is already present. The last flag is write only. It means the file is only meant for writing. We will use 0666 as the file mode. This function returns a file pointer and an error. Let's format this for better readability. If there is an error in reading the file, panic here. In the JSON handler, replace standard error with the file pointer. That's it. Let's see how it works. This time there is no output on the terminal. Let's check the file. Logs are now sent to a file. We have hard-coded the file path in the code. We should use environment variables for such purposes. We have explained how to use environment variables in episode 17. We missed closing the file here. Let's defer the file closure here. Now we will send the logs to the file and to standard error as well. We are going to use io.multiwriter for this. It takes multiple writers as arguments. Let's pass the file pointer and standard error. Put this into a variable. Replace the writer in the JSON handler with the multi-writer. Now when we run the program, the log is printed on the screen. Let's check the file. It goes to the file as well. I don't prefer writing to the file. There is an elegant way that the Linux command line provides to redirect logs to a file. First, let's remove all this code and bring back standard error. Now, when we run the program, we redirect logs to a file with this command. This part opens the file in append mode and redirects standard output to this file. Here we redirect standard error to where standard output goes. Check the file. The logs are redirected to the file. I would recommend adding log rotate on log files in production systems as they grow in size and cause the disk to become full. And there you have it, folks. Thank you for joining us in this episode. If you have any questions or topics you'd like us to cover in future episodes, please leave a comment below. Don't forget to like, share and subscribe for more developer insights and tips. Until next time, happy coding.